Hello friends, I am Aditi Kumar and welcome to another session related to specially perceptron. So in our last video, I discussed about how we can implement logical gates using single layer perceptron. So in this session also we can discuss more gates which can be implemented using a single layer perceptron. But the thing is, it looks like this is the problem of a multi-layer perceptron, but still you can implement using single layer perceptron. And second, there are some category of logical gates, I can say some special type of logical gates which cannot be implemented using single layer, so that we can implement using multi-layer neural network. So let's dig dive and discuss about these topics today. So specially uh, in the last video, so I explained the logical gates point of view: AND gate, OR gate, NOT gate. These are three basic gates which can be implemented using a single layer of perceptron or neural network. But I mentioned in our last session also NAND gate and NOR gate cannot be implemented using single layer, but we need actually multi-layer for the implementation of this particular NAND gate and NOR gate. But that exactly not the case for always, but we can make it using maybe I can say multi-layer network, but still you can manage it using single layer. But I will explain dig dive maybe in detail today. So especially today we will discuss how we are basically implementing the some special logical gates using multi-layer perceptron. So especially NAND gate, NOR gate, XOR gate, XNOR gate. So out of these, I can say it's written actually these four gate cannot be implemented using single layer perceptron, but that always not the case. So but I can say if you can separate these two, NAND gate or NOR gate, still you can implement using single layer possible, and XOR or XNOR multi-layer, I can say. So why it is basically not possible using single layer? Because whatever the input space, I can say, for this particular gate, we cannot separate using a linear separator or linear decision boundary, right? So especially I will focus today is a XOR gate for multi-layer maybe implementation, and NAND gate or NOR gate, still we will implement. I will explain how we can implement using single layer. Okay, so let's start with a NAND gate. So if you will basically talking about NAND gate is nothing but a, so this is a AND gate. If I am putting a NOT, this is basically NAND gate. Complement of result of the AND gate, especially this is the AND gate. And yesterday we maybe I can say in our last session we saw how a linear boundary can separate all the input space in the AND gate. But today we will see how in case of NAND gate how it is also possible, right? So let's explain more on that. So if I am talking about input space, here suppose x1 and x2, right? So I am taking two input 0 0 0 1, combination is 4 1 0 1 1. So always basically x1 and basically the output is always 0 0 0 1. If I will take a complement, then NAND gate, and always basically the output will be like this. So if I will basically decision boundary perspective, so if I am taking two boundary here x1 and x2, always basically it will be like this, the 4 point, this is my 0 0, this is my 1 0, and this is my 0 1, this is my 1 1, right. In case of 1 1 only, this value is 0, so other than it is basically 1. And using a linear boundary, I can say we can easily separate that. So which equation is basically, I can say z equal to x1 w1 plus x2 w2 plus maybe I can say b, or maybe I can say decision boundary is x1 w1 plus x2 w2 plus b maybe equal to 0, or maybe get greater than 0, greater than equal to 0. So we explained basically. So the thing is, still NAND gate can be implemented using single layer. But why I was explaining this is a multi-layer? No. So for example, if you will implement for a maybe I can say this is the 2 layer, one layer is basically I can say for AND gate, then in that case second layer will be for NOT gate, then again basically it can be also, it will work in the same way, but still efficient way. This is for NOT and this layer is for AND, but definitely we can make it in a single layer. For example, this is my network, suppose this is x1, then w1, then x2 w2, this is our bias, then this is your summer. So maybe this is basically x1 w1 plus x2 w2 plus b, right. Then actually we are passing through a sigmoid function, then a classifier basically I can say, then which can be we can generate basically a NAND gate result which is a 0 or 1, right, 0 or 1. It can be possible using a single layer. This is basically I can say the artificial neural network. This is the artificial neural network, because this is a combination basically. This is not separate. This will come in a, I can say, a black box, right. This is basically the beauty of NAND gate. So if you are talking about NOR gate, so NOR gate is nothing but a this is OR gate. If I am putting a gate here NOT, this is NOR gate. This is the replication of OR gate. And the same thing. So it looks like this is basically one layer is for OR, then another layer is for NOT. But we can say still you can implement using multi-layer, but it is not required. It is unnecessary. We can make it using single layer. So let's dig dive into that how it is possible. So again I am taking x1, x2. This is my OR gate result, right. So 0 0, 0 1, 1 0, then 1 1. So my OR gate will be 0 1 1 1. So if I will take NOR gate, which is the replicate 1 0 0 0, right. So if I will plot in the 2-dimensional plane, then x1 or x2, then still this is 0 1, this is my 0 0, and this is my 1 0, and this is my 1 1. For 1 1 the value is basically 1 1, it is 0, this is 0, this is 0, this is 1, then still we can make it like this, right. So that is basically I can say we can make it separable. We can separate basically the two the input plane using a linear decision boundary, which may be w1 x1 plus w2 x2 equal to 0 plus b equal to 0. So this is basically the decision boundary. It can linear decision boundary which can separate the input plane into two parts or two different classes. So using a linear boundary, then still it is possible using a single I can say single layer, which may be, this is the my combination actually sigmoid, and this is just this is basically x1 w1, then x2 w2, then this is b, right? Then this is the sigmoid, this is basically our classifier, then this is our NOR gate output. This can be possible still, but there is some special case in case of XOR gate. So in the XOR case, basically it is quite different from AND or NAND NOR, right? So here we cannot implement using single layer. Here multi-layer implementation is mandatory. How it is required, then let me explain. So if I am talking about x1 and x2 are two input, and this is basically the XOR, I can say the 0 0 0 1 1 0 1 1, right? Always the XOR output will be 0 1 1 0. This is the XOR output. But how it is basically getting derived, let me explain here, right? So this is x1 x2 0 0 0 1 1 0 1 1. Okay, if I am taking, I can say OR gate first, right? Then this is, I can say 0 1 1 1, right? Again I am taking AND, right? This is 0 0 0 1. So I am taking NAND, that means the complement of AND 1 1 1 0. And again here suppose I can say this is your A, this is your B, this is your C. Then if I am putting A your AND C, right? If your A and C I will put, I will always get 0 1 1 0, which is a same output like XOR. So let me explain the decision boundary and network, right? So if I am plotting the decision boundary, here there are two input x1 x2. So for 0 0 it is basically 0, right? This is your 0 0, this value is 0. If you are talking about 1 1 1 1, this value is still 0. If you are talking about 1 0, right, its value is 0, right? Its value is 1, sorry. And if the value is basically 0 1, its value is 1, right? And here there is not, maybe I can say it is not such a way that we can separate the entire input space using a linear boundary, because here basically this is one category, here this is one category. We cannot make it separable using a straight line, I can say linear boundary. For example, I can say there might be something like this, right? The boundary you can put like this, right? But again, this is not a linear, this is a non-linear, right? So in that case, the implementation perspective, I can say if I am talking about here one layer, it is basically which is basically, I can say input layer, and another layer will be a hidden layer, then another layer will be a output layer, I can say output layer. So output layer is our classifier, so this is our hidden layer, right, which is basically a maybe a combination of neurons, two neurons actually, I can say. This is our input layer. So let me redesign again. So this is basically two input, I'm talking about your x1 w1, same also giving here, okay, this is x2 w2, right, giving here, right. Then same maybe here some b or same b actually here. Then we are having two layer, right, here like this, right, like this. Then finally we will have a output layer, maybe some classifier, then you will give a output. This is basically 0 or 1, right. This is basically this type of architecture is mandatory to implement this type of gate. The same actually same way if you will interpret for XNOR, so it will be like this. So using some hidden layer only we can implement this type of network. So these are basically whatever I explained in the two session. I divided into two sessions specially. So I can say something maybe I can say here, it was basically some basic gates, right, some basic gate implementation. But in the real scenario, think like this is a real scenario, but in the real world basically this is not exactly the problem statement. The problem statement is very complicated, right. But the way we can think to design the architecture and algorithm is like this. This is the foundation, right. So that's why maybe we almost cover some basic concept of the neural network, how it is basically internally it works, then how we can start designing or thinking design perspective. So then maybe later stage, maybe going forward, I will try to pick some special concept which is related to neuron. For example, activation function, maybe what are the maybe appropriate activation function, so problem statement wise, right. So this type of thing, maybe if you can get clarified first, then maybe you can take some problem statement and start implementing. Then we will go for coding and some libraries how can implement effectively, right. So that's why I'm covering actually some basic concept first, so that simultaneously related to some Gen AI also mathematics, some optimization, some deep learning, machine learning, some foundation or maybe some fundamental concept actually I'm trying to cover first, so that gradually we will dig dive into more complicated things, so that it will be a easy path to understand from basic to higher level. Then maybe last stage maybe you will able to implement these things in the different domain, in the different real scenarios. Okay. Thank you very much for watching this particular video. Please do subscribe my channel and share this particular video, and also put comment under this particular video, so that it will be helpful for me. So maybe starting from next video onwards, then I will pick some more deeper concepts into neural network or maybe Gen AI. So it will be basically into respective playlists. So entire the separate playlist will contain the respective details or maybe concept related videos. So it will be pretty easy to go through under this particular playlist. Once again, thank you very much for watching this particular video.